Hey guys, it's Mr. Riz, and today what we're going to do is finish up P5, the pre-calculus with inverse functions, and we're going to try to find the inverse functions algebraically. Then we will also determine if those are inverse functions as well. So when it comes down to finding the inverse functions, it's pretty simple. What you need to do is 4 steps. First thing we're going to do is change f of x to y. I think it's a lot easier if we think of f of x as just a single letter variable. Then what we're going to do is take the equation. We're just going to switch all x's to y's and all y's to x's. We will solve for y, get that y by itself, and then at the end, change that y to the proper notation of the inverse function of f. So we're going to go through these couple examples here, make sure we can handle them. And they might get a little scary, but we'll be all right with it. So let me start to annotate here. And here we go. So first thing I'm going to do is change this to y equals 2x. Then the next thing to do is switch the x and y's around. So I'm going to make this x equals 2y. If I had to get that y by itself, I would divide by 2. So x divided by 2 is y. And then to write it properly, I'm going to change the y to the inverse function of f. So the inverse of f of x will be x over 2. Okay, we'll keep it going. If you guys ever want to pause this video, try some on your own, feel free to do that. Skip ahead. Here we go. Next one, we got y equals 7x plus 1. I'm going to change that to x equals 7y plus 1. So I would subtract the 1, then divide by 7, divide the whole thing by 7. And there we go. We got the y by itself. So the inverse function of f, I lost my drawing tool there, is x minus 1 over 7. All right, let's just keep it going. Next, okay, x cubed over 8. So y equals x cubed over 8. So let's change this to x equals y cubed over 8. All right, if I had to get rid of the over 8, I'd times the other side by 8. And so I would get 8x is equal to y cubed. And then to get the y by itself, I take the cube root. So I do the cube root of 8x. Now, if you just leave it like that, it's fine. Technically, we can split this up. The cube root of 8 is 2. So I'm going to make it a little fancy. I'm going to say 2 times the cube root of x equals y. Or final version, the inverse function of x equals 2 times the cube root of x. We were doing good so far. If you ever have trouble, just pause the video, go back and try to see where your mistake was made. Here we go. Next one, we got y equals the square root of x minus 4. Well, we're going to change that to x equals the square root of y minus 4. Got to get rid of the square root by squaring the other side. So x squared equals y minus 4. We'll add 4 over. X squared plus 4 equals y. So the inverse function here is x squared plus 4. So hopefully these aren't too bad. Nobody's brain is freaking out yet. All right, well, speaking of brains freaking out, let's scroll down, do the next couple. All right, this one isn't too bad. Here we go. We would change this to y equals 9 minus x squared. Then switch that around. And if you want to do the first 2 steps, that's fine with me. X equals 9 minus y squared. All right, so if we had to get this y squared by itself, first thing I would do would be to subtract 9 over. So x minus 9 is equal to negative y squared. Have to get rid of the negative, so I'd multiply the other side by negative. Now I'm going to, instead of writing negative x plus 9, I'm going to change this to 9 minus x. That is a negative x plus 9. It just looks a little bit better that way. All right, then we got to take the square root. So we'd square root the whole thing. There we go. We got the y by itself, so we can say the inverse is the square root of 9 minus x. All right. Next problem. Ooh, okay, so I'm going to start over here. We got y equals x minus 1 over x plus 5. Well, the first step is to change all the x's to y's and y's to x's. So we'd have x equals y minus 1 over y plus 5. So we have to get the y by itself, but you might be looking and be like, well, there's more than one y. We can still get it by itself. So if we're dividing by y minus 5, I can take the other side, x, and times it by y plus 5, and still get the y minus 1 alone. So I took this bottom here and I multiplied it by the other side. Okay. Then the next step, I'm going to distribute the x. I don't like having parentheses, so I get x times y is xy, and then plus 5x equals y minus 1. Okay, so we still have multiple y's here, but we're going to do a trick in 2 steps. The next step is we're going to get all the y's on the left side and anything that doesn't have a y over to the other side. So I'm going to leave this xy here on this side, but I'm going to minus this y over, and then I'm going to minus the 5x over. And I'm going to leave that minus 1 on this side here because it doesn't have a y. Now, the reason why we do that is because now, since both of these have a y on the same side, we can factor out the y. We can take away a y from both of these. This becomes an x minus 1. And the other side is just still negative 5x minus 1. Now, the reason why that is important is because once we factor out the y, that y is almost by itself. It's just being multiplied by x minus 1. So if I take the other side and divide by x minus 1, divide by that term, I now have the y by itself. So the inverse function is negative 5x minus 1 over x minus 1. Okay. So we can find these inverse functions and we could graph them to double check that they are inverse functions, but that's not the only way to do that. Another thing that we can do is to verify that they are inverse functions. And we can do that by a really quick check here. All right, hopefully you can maybe do this in your head, but if I have f of x equals 4x, the inverse function of that would be, okay, switch them around, divide by 4, that'd be x over 4. So there's something really special here if we use our composite functions. If I take the inverse function and plug it into f of x, let's see, if I took the inverse function, x over 4, and plugged it into the original function, I would just get x. If I did it the other way too, if I took the original function and plugged it into the inverse function, I'd still get x. So if you ever take the inverse and plug it into the original, or vice versa and get x, they are inverse functions. So let's verify that these two are inverse functions. We're going to take one equation and plug it into the other. And it doesn't matter which order we go. I'm going to take this one, plug it into there. So what is the square root of x squared? That is x. So yes, they are inverses. All right, which one would be easier to plug into? Would it be easier to plug the 3 minus 4x into this, or take the fraction, plug it into here? I think it'd be easier to plug this right into there. So I'd have 3 minus, not x, but 3 minus 4x all over 4. So distribute the minus here. I got 3 minus 3 plus 4x over 4. The 3's cancel out. I get 4x over 4, which is just x. So yep, that is also an inverse. All right, let's clear this out, see a couple more to do. Okay, now they're getting crazier, but we're smart, we're good kids. All right, what would be easier? Okay, plug the cube into this thing here, plug that. All right, I think it's gonna be easier for me to take this, plug it into here. So instead of x cubed, it's going to be 8 cube root of x cubed over 8. Now, if I cube a cube root, it just becomes x. And then if I cube 8, ooh, that's a pretty high number. I think that is 512. So 512x divided by 8 is 64x. That is not a single x by that side, so that is a no. No, didn't work. Okay, well, Let's try this next one, see what happens. Okay, what's going to be easier? Take this, plug it into here, take this. I'm going to take this one, plug it into both the x's. Fingers crossed we get something that works out right. So we're going to get a 2x plus 3 over an x minus 1 plus 3 over a 2x plus 3 over an x minus 1 minus 2. All right, how do I simplify this? Well, let's work at each part here. At the top here, if I want to add 3 to this fraction here, I'd have to get common denominators. So I'm going to have to, I changed the color there. I'm going to have to multiply this by x minus 1 and this by x minus 1. And so the top becomes, well, we'd have a 2x plus 3 over x minus 1. And this one would be a 3x plus 3, or 3x minus 3, because that makes a big difference. 3x minus 3 over x minus 1. At the bottom, I would have to do the same thing, right? If they both have an x minus 1, I'm going to have to multiply this by x minus 1 to get common denominators on this half. So I get a 2x plus 3 over x minus 1, and then I would get on this side here, I could put plus, I'm just going to put plus negatives here. A negative 2x plus 1 over x minus 1. Yep. Okay, well, now that we have like terms, common denominators, we can just make this one fraction on the top. So 2x plus the 3x gives us a 5x. The 3 and the minus 3 go away. We're left with an x minus 1. Now, on the bottom fraction here, if we combine these, we got a 2x and a minus 2x, which becomes, I made a mistake. I did see this here. This should be a plus 2. Sorry, I was thinking ahead of what was going to happen here. All right, the 2x and the minus 2x goes away. I forgot to distribute the 2 there. And we'd get the 3 plus the 2, which is a 5 over an x minus 1. All right, well, if we have this fraction dividing by a fraction, remember, dividing by a fraction is the same thing as multiplying by the reciprocal. So 5x over x minus 1 divided by this fraction would be the same thing if I multiplied by x minus 1 over 5, multiplying by the reciprocal. So a nice thing about there, the x minus 1's cancel each other out because they're on opposite terms. And we are left with 5x over 5, which is just simply x. So, long journey there, but yes, we did it. We found the inverse functions. All right, so does that wrap up this note section here? Yeah, because we got homework that we're going to do. All right, so today what you guys are going to be doing is the CYU. I've had a couple suggestions to double check the CYU work, so make sure you guys are okay with those. And so I will do that right now. So you guys have part 2 here. Let's take a look at the quiz. All right, so you just need to determine at the beginning whether these are inverse functions, yes or no. Hopefully you take your time, you can plug one into the other and make sure it equals x, or do some other things to verify. So those don't look too bad, too bad. Is this all we're doing here? All right, so you have a true-false quiz that you guys are allowed to take as many times as you need. Think you'll be all right. All right, great way to end this unit here. We'll start P6 tomorrow. Have a great